Welcome to my lecture. Today we are going to discuss the Fourier transform, and this is the module 2 of the course mathematical method. So what is Fourier transform? So to know the Fourier transform, we should know about the Fourier integral formula. So this is our introductory chapter, the Fourier integral formula. Fourier transform is an integral transform like the Laplace, and this transform have wide level of application in science, engineering, and in the field of medical and signal processing. And in this module, we are going to learn following topics: basic formulas and theorems of Fourier transform, and solution of ordinary and partial derivative equation using Fourier transform. So now that what is Fourier integral formula? For that, we recall about the definition is Dirichlet condition. So a function fx, real function, is said to satisfy Dirichlet condition in the interval minus a to a, open interval minus a to a, if fx has only a finite number of finite discontinuous continuities in minus a to a and has no infinite discontinuities. Fx has only a finite number of maxima and minima in minus a to a. Next definition is absolutely integrable. A function fx is said to be absolutely integrable on minus infinity to infinity if minus infinity to infinity absolute of f of x dx is less than infinity and exists. Now next is Fourier integral theorem. If the function fx satisfies the Dirichlet condition minus infinity to infinity and is absolutely integrable on minus infinity to infinity, then the integrals this is convergent to the function f of x. If the function fx satisfies the Dirichlet conditions is minus infinity to infinity and is absolutely integrable on minus infinity to infinity, then the integration 1 converts to the function half fx0 plus fx minus at infinity at finite discontinuity at x. In other words, this expression can be written as the integration this one. If the function fx is continuous at a point x, then fx plus 0 plus means x from right side, and fx minus 0 means it is from the left side of x. This is equal fx, and from 2 we have f of x is equal this function. So this is the Fourier integral theorem. Express is more details than the previous theorem. Okay, now we come to the next section, and it is basic formulas and theorems of Fourier transform. This section is divided in several subsections. First subsection is definition of FT, Fourier transform. Suppose that ft is a piecewise continuous on minus infinity to infinity and ft is absolutely integrable. That is the integration minus infinity to infinity. Absolute value of f of t is less than infinity. Then the Fourier transform of a function f denoted by curly f ft is given by So this notation f omega is equal f of ft minus infinity to infinity e to the power minus iota omega t f of t dt. So clearly the integrations, the outcome, if it is converged, then it will be in terms of the omega, and that function is we denote as capital F omega, and it is the Fourier transform of the function ft. Next is the inverse Fourier transform. Suppose that minus infinity to infinity f omega, capital F omega d omega converge, then the inverse Fourier transform of f omega, denoted by this notation, is given by 1 over 2 pi minus infinity to infinity e to the power iota omega t f of omega d omega. So therefore this will be a function of t, and that's is our ft, whose Fourier transform we calculate. You will get that functions back. So in this problem, we are going to find the Fourier transform of ft is given as by the, this equation. Ft is equal a when minus L to L, t range is minus L to L and 0 otherwise. And here we consider a is a positive number. A is greater than 0. So how to solve it? The first we will take the discuss about the absolute integrability of the function ft. So minus infinity to infinity absolute value of ft dt. Since a is positive, we can write it minus L to L a dt, and which is just a finite integration and always be convergent. So this so that the function ft is absolute integrable. Now we will get the Fourier transform of this ft, so which is given by the integration minus infinity to infinity e to the power minus iota omega t ft dt. Now what is ft? Ft is defined with by a between minus L to L and other part 0. So therefore this integration is limit up to minus L to L. And then if we want to solve this integration, so this is e to the power iota omega t. A is constant going out, so e to the power minus iota omega t will have the integration e to the power minus iota omega t divided by minus iota omega, and limit is minus L to L. Then we have here this limit we substitute, so e to the power minus iota omega L minus e to the power iota omega L. So if you take out the minus, or this one is nothing but sine iota sine omega L. So therefore this minus and minus will become plus, and then answer is, and this iota will cancel out, then finally answer is a over omega sine omega L. And this is the final answer for this problem. So we'll continue with more problem in the next lecture.